Hello, welcome to Geometry today, and it is Thursday, March 26th, and we're going to go over your test here real quick. You're going to get another chance to do better on it than you did the first time if you watch this video. If you don't watch this video, you could redo it, but I'm not going to take your score, so please watch this entire video, okay? Um, all right, well, I'm going to go over 6 of the 10 problems on your last test. And these questions, at least 2 or 3 people missed. All right. Number one, most important thing is that you guys see the difference between these shapes here and the properties that they have. This slide right here, which I've been showing you over and over again, is the most important thing for you guys to use on your test, okay? So there are properties that apply for all parallelograms, and then ones that are only rhombuses, diagonals form perpendiculars, diagonals bisect the vertices, all right? And then only rectangles, diagonals are congruent only in rectangles, or isosceles trapezoids, but that's nothing you have to worry about for this test. All right. Squares have all of these properties. Everything up here, squares have, okay? So make sure you use those. All right, let's look at this first problem here. What must QPS be for this to be a parallelogram? Okay. Well, in order to figure out what QPS must be, okay, don't just do like eeny, meeny, miny, mo. You have to try to figure out these angles in here, all right? And so you need to get your pencil and paper and show some work because none of you guys, I mean, you might be able to do it mentally, but probably not, just to be safe. Okay, so in a parallelogram, what property am I using here? Okay, let's see. Opposite angles are equal. Okay, so that's the property I'm using here. Opposite angles are equal. So we need to solve for x here. So I'm going to subtract 6x from both sides. I'll get 13 equals x minus 5. If I solve for x, I will get x equals 18 because I'm going to add 5 to both sides and I'll get 18. All right? So I need to figure out what that angle is. QPS. Now, I cannot get QPS by direct substitution because QPS doesn't have a particular x associated with it. But I can get this angle Q here by direct substitution. So I'm going to take my 18 and plug it in. So I'll have 6 times 18 plus 13. Okay, 6 times 18 plus 13. So a quick little bit of mental math. That would be, let's see, 6 times 8 is 48. Carry the 4, 108. Okay, plus 13. And so that would be 131. Okay, 121. Yes, 121. Okay, so if you have 121, they're going to want you to pick C. Okay, but remember what we just found. This is Q. This is angle Q. Q right here is 121. Okay, if I want to figure out angle P, okay, remember in a parallelogram, same side interior angles are supplementary. Okay, so these two equal 180. So if I'm looking for the one that they want us to, QPS, I am subtracting from 180 degrees. Okay, so for QPS, I'm doing 180 minus 121 to get 59. All right, so there you go. Hopefully that one makes sense now. All right, let's go to the next one. All right, did you use paper and draw out the picture? That's the very first thing I'm going to ask you, okay? Because if you didn't, you're being foolish and you're guessing. So you can't be foolish. You have to draw the image, all right? So please do that. Okay, P is in the middle. It's parallelogram ABCD. So you're going to put A. Okay, then you could go either here or here. It doesn't matter. You have to go one. You cannot go there. Okay, so A, B, C, D. All right, so like I said, you could switch B and D around. All right, what statements must be true? Now, this is just a parallelogram, okay? It's not like a rectangle. It's not a... So we can only use statements about parallelograms, okay? Is AP the same thing as CP? Okay, well, AP is the same thing as CP because diagonals bisect each other. Look at the picture here. You see how these diagonals are crossing and they're congruent? So yes, that is true. Okay, boom. Is BC the same thing as AD? And that is also true. Okay, why? Let's go back here. Opposite sides are equal. Got it. Is ABC equal to 90 degrees? No, because we don't know if it's a rectangle or not. Okay. Is CAD the same thing as ACB? Okay, so okay, so this one's the tough one. Okay, you got CAD right there and the little red dot, and then you got ACB. All right. Now, this one, what do you think? Is this true or is this not true? This one is true, okay? Why this is true is because of alternate it's a parallelogram, so you have parallel lines and alternate interior angles are equal, okay? So, see, here's the transversal AC, and this is on one side, and this is on the other side of that transversal. So, yes, the third one is also true. You have to click all of them to get credit for this problem. All right. All right, okay, we're back here with number 5. This is actually my second time recording number 5. This one's a little bit tricky here. In fact, I have decided there are 2 possible answers for number 5 after looking at it further here, and I'll explain here in a second. But first, draw it out, go clockwise or counterclockwise with your letters. You have midpoint R, which means that WR is the same thing as YR, and ZR is the same thing as XR. Doesn't mean the diagonals are congruent, so you cannot directly say that is a rectangle, because in a rectangle the diagonals are congruent. Now remember, to be a rectangle you have to have 4 sides, and you have to have either the diagonals being congruent or you have to have 4 right angles. Okay, so let's see which one gives us that information. WX is the same thing as YZ. That is not enough, because that is true for all parallelograms. All right. For letter B, WY is the same thing as, or WY is perpendicular to XZ. That is true for rhombuses, not necessarily for rectangles unless it's a square, so that one's out. WXY is equal to 90 degrees. All right, so since the diagonals are bisecting each other here, we know it's a parallelogram, okay? And since we know it's a parallelogram, we know that opposite angles are equal, so we could say that this angle is equal to 90 degrees. All right. We also know same side interior angles are supplementary, so that would give us 90 here. That would also give us 90 here. And so that would be enough for it to be a rectangle. So yes, that is one of the possible answers. And no, the book did not think this was the possible answer, so I will need to give you guys some credit if you picked C on that one. For D, okay, D is also a possible answer, because if WR is the same thing as XR, you could put markings here to show that. And then remember, ZR is the same thing as XR, so you could put markings there. And then by theorem, diagonals being congruent makes it a parallelogram. Oh, no, it makes it a rectangle. Yes, that's what we're trying to prove, a rectangle. All right, so you got 2 answers there. Looking at this next one, what is true about rhombuses? Okay, remember, rhombuses inherit all of these properties from parallelograms, and also these 2 here. Diagonals form perpendiculars, diagonals bisect the vertices. So, going back to this question about rhombuses. Opposite angles are congruent. Yes, that's in all parallelograms actually. Diagonals are perpendicular. Yes, that's only for rhombuses. Diagonals are congruent. No, that's for rectangles. Opposite sides are parallel. Yes, that's for all parallelograms. Okay? Question about this square. What is true about this square? All right, let's look at this. FP, here's FP, from there to the middle, is the same thing as 2EG. Okay? EG is the long one. Double it is not FP. Okay, that is wrong as can be. All right. EP is the same thing as EH. EP halfway is the same thing as EH. Oh, no. EH is down here. Okay, so in a square, you have equal diagonals, okay, and diagonals being bisected. So you have this, but the sides themselves, they're not equal to half of the diagonal. Okay, and you could tell that because each angle in here is not a 60-degree angle, okay? Because you have 90 degrees here in the middle. You got a 90-degree angle there in the middle, which means each one of these has to be 45. So this angle here has to be 45. And then this EH is going to be a not, it's opposite a 90-degree angle, not opposite of 45. So it's a longer length EH than that one. So that one's off. Like I said, each angle is 45 degrees. So this one is true. Okay, EFH is going to be 45 degrees. And FH is perpendicular. Yep, because this is a rhombus, and so it has that property. All right. Number 7. What is the most precise classification? All right, so let's think. To prove that it's a parallelogram, we have to prove one of these things being true. Okay, let's see if we can do it. So let's see if we can prove that this is a parallelogram. Are both pairs of opposite sides congruent? No. We only have one pair that's congruent. Do we know anything else about it? No. Okay. It's not a rectangle. We don't know anything about the angles. You might think it's a trapezoid, but we don't know if anything is parallel here. In a trapezoid, you have to have one pair of parallel sides. In this particular one, you have no definite sides that are parallel. Okay, so the only thing you could say about this one is that it's a quadrilateral. All right, so hopefully that helps you. The retest should be similar, and you might have an extra 10% because of that one question, which was a little tricky. So just give it another try, and hope for the best for you guys, and we'll talk to you later then. Thanks.